I'm excited to give everybody an update on Cobalt Hybrid St. Augustinegrass, a couple of studies that we've been working on over the past 2 years with emphasis on cobalt's drought tolerance and its potential reduced fertility requirements. So that's something I will talk to you all about today. So just as a little bit as a memory refresher for everybody, this project that resulted in the development of Cobalt St. Augustinegrass was started back in 2003 as a result of interest and support from a subgroup of producers in Texas called the St. Augustine Research Group. So these are the members of TPT who back in 2003 engaged with Texas A&M and with an idea to develop new and improved St. Augustine grasses. And this was the subgroup of growers in Texas who sort of had the foresight that in order for St. Augustine grasses to remain viable in our industry, we really need to be working towards improving its drought resistance. And so these are some of the traits where all the SARG members were asked to rank these traits in terms of how they perceive the importance of these traits in new and improved varieties. And so clearly, the drought resistance was ranked number one by the SARG members of TPT, closely followed by disease resistance, closely followed by insect resistance, and then turf quality. Notice that cold tolerance was ranked at number 7, and part of that is because the most predominant variety of St. Augustine grass in Texas is Raleigh, which is the standard for cold tolerance. And so, but there was a need to improve drought resistance and disease and insect tolerance over Raleigh. And so that's sort of this ranking is an indication of where our growers saw the need for biggest improvement. So again, of course, drought resistance was our number one trait, and using embryo rescue technology where we were able to create this hybrids of St. Augustine grass where we crossed plants with good drought resistance and crossed them to plants that have good turfgrass quality characteristics, good shade tolerance. And the idea is to bring the best of both worlds into new hybrids. So, trying to.
Is it working?
Advance.
Oh, there you go. Okay.
Okay, so Cobalt, the cross that resulted in the development of Cobalt was made in 2010, and during about the same time, we were very fortunate. When I say we, the southern or the warm season turfgrass breeders, we were very fortunate to have received federal funding from USDA NIFA Specialty Crops Research Initiative project, which started in 2010, which allowed all these 6 institutions that you see here on the screen to exchange their germplasm, to exchange their hybrids, and then those hybrids be evaluated in all these 6 different states and multiple environments and with different types of soil and weather conditions. So this was a huge opportunity for us to be able to, that enabled us to do this multi-environment testing. And so Cobalt became part of this SCRI project in 2012. Remember, the cross was made in 2010, and we entered Cobalt into this SCRI trial in 2012. And so we were able to evaluate hybrids like Cobalt through this program for over a period of 10 to 12 years. And that is something very unique. A lot of projects, they are 2-year, 3-year, 5-year term. This project lasted for over a decade. And so this was a perfect experimental setup to sort of understand the genetic gain that we were able to achieve, especially in drought tolerance, which was the objective of this project, was to improve drought tolerance in warm season grasses. And so this is sort of the data that this graph here that you see is sort of a culmination of 12, 13 years of work where cobalt was evaluated in multiple environments across those different states that I talked about in my previous slide. And we were able to estimate what is the genetic gain in terms of drought tolerance in cobalt, for example, here, over Palmetto and Raleigh. These are the two standard cultivars that have been in the market and have done remarkably well. And so if you look at this graph, what you're seeing is that the light colored bars here are turfgrass quality data collected under drought conditions at all those multiple locations across those 10-year period. And the dark gray color bar here shows the turfgrass quality of these cultivars under non-drought conditions. Okay, so what these numbers here show is that cobalt shows about 40% genetic gain over Palmetto and about over 50% genetic gain over Raleigh under drought conditions. When you look at it, evaluate it under non-drought conditions, you can expect to see about 19-20% genetic gain in cobalt over Palmetto and over 32-33% genetic gain over Raleigh. And so these numbers are huge. This is a significant improvement when it comes to drought. And also under non-drought conditions, you're seeing cobalt to have superior, better turfgrass quality as compared to Palmetto and Raleigh. And again, this data was done, across multiple locations, across multiple years. And so that's the beauty of this trial, this study, this SCRI study. And so really, I want to just say thank you to all the breeders and the collaborators of this study. We, worked so cohesively, so collaboratively together to generate data like this. We have seen the drought tolerance potential of cobalt, but when you put it on a graph like this and you actually see, you can quantify the genetic gain, over Palmetto and Raleigh, it gives you that sense of confidence that, yes, this truly is a drought-tolerant cultivar. Okay, so moving on, I want to talk about this Water My Yard study. This study started here at the Dallas Center with Texas A&M AgriLife Extension and Research in 2022. So you may or may not be familiar with the Water My Yard program, but Water My Yard program was really the brainchild of Dr. Guy Phipps and Charles Swanson of Texas A&M AgriLife Extension Service. This program was started in 2014, so about 10 years ago. And really what this program does is that it uses the local weather data to provide weekly watering recommendations to the subscribers of this program. So, for example, these are some of the cities in Texas and municipal water districts that are sponsors of Water My Yard program. So these are the partners of Water My Yard program. And any cities that fall under their jurisdiction and any residents of these cities, they can freely sign up for Water My Yard program, and they will get a weekly email saying that based on your zip code and based on the weather station near to your house, this is how much water you should be applying this week. And in order to apply this much water, you need to run your irrigation system for this long. So it's a very practical and applied sort of a program, but it's based on data and based on science. So it's been very useful for the users and subscribers of this program. So how does this work? So those weekly watering recommendations, right, that the ones that Water My Yard program uses is based on this equation, which is ETO times KC times AF. Now, ETO is reference ET. So it is the evapotranspiration from a well-watered, mowed, cool season grass. And this is the sort of data that you will get from your local weather station. Now, this ETO, or reference ET, is multiplied by a crop coefficient called KC, crop coefficient, to adjust this reference ET to the specific crop that we are working with. So in this case, we are working with warm season grasses. And the standard, the constant crop coefficient used for warm season grasses is 0.6. So you multiply ETO with 0.6. Now, there's another factor here called adjustment factor, or AF, right? So Water My Yard program uses the adjustment factor of 0.6, which means normal stress on your grass. So the grass will look stressed, but it's normal stress. What would you qualify as normal stress, right? And then, but if you have lower tolerance for stress and preference for greener, less stress grass, then you can change the adjustment factor to 0.8 for low stress or to 1 for no stress. Or if you are looking for water savings and you can tolerate a little bit more stress on your grass, then you can go and take the adjustment factor to a step lower to 0.5 for high stress or 0.4 for very high stress. So see how you can adjust the watering recommendation or watering based on what's your tolerance for stress level. So again, for Water My Yard, the formula goes ETO, which is obtained from weather station, times 0.6 for warm season grasses, times 0.6 adjustment factor for normal stress. So in this study that we started in 2022 here at the Dallas Center, we wanted to look at two different things. We wanted to look at 4 different adjustment factors. So this normal is what the Water My Yard program uses. We wanted to test the grasses under 1 level up and 2 levels down. So we tested under these 4 adjustment factors. And then these 5 varieties of warm season turf grasses were tested: 2 Bermuda grasses, Tifway and Tiftuff, 2 St. Augustine's, Raleigh and Cobalt, and 1 zoysia grass Palisades. And so all these 5 cultivars were replicated 4 times within each adjustment factor. And this is how the study is laid. This is this photo here is the thermal image, and on the right side is the multispectral image, aerial image of the whole study. So in 2023, last year, this trial this study lasted for 15 weeks, and 9 out of those 15 weeks, we had no rainfall. So consecutive weeks without rainfall. 5.68 inches of rainfall was received during that 15-week period. And if you look at the amount of supplemental irrigation applied for each of these 4 levels of adjustment factor, you're looking at for 60%, which is the recommended amount, recommended adjustment factor, 8.51 inches of supplemental irrigation on top of the rainfall received was applied. If you go 1 level up, 80%, you're looking at 11.57 inches. At 50%, 7.04%, which is, I think, a 17% reduction in water from 60% adjustment factor. And then at 40%, at 5.57 inches, you're looking at, I think, over 30% or 34% reduction in water from the recommendations. Okay. So this is the data from 2023. The study, we repeated the study in 2024. We are currently summarizing that data now, but the results were similar to what we saw in 2023. So let's look at the 0.8, 1 level up than the recommended amount. The black dotted lines show the start and the end of that 15-week period of study. The red horizontal line here shows the minimum acceptable quality of 6. So the quality, turfgrass quality, was rated on 1 to 9 scale, 9 meaning excellent, 1 meaning dead, 6 is the minimum acceptable. So that's the red line. And you can see all these different colored lines here, the curve of representing different cultivars. So basically what you see is that at 1 level up, at 80% adjustment factor, most of these varieties were able to retain a quality of 6 or above 6 throughout the period, that 15-year period. And that red or that pink or magenta dotted line is cobalt. So there's cobalt. maintaining its quality above 6. Now, if you look at 0.6 adjustment factor, which is what the Water My Yard program uses as the standard recommendation, again, you see that some of these cultivars declined and went below the minimum quality of 6. And if you look at cobalt right here, here's cobalt. And it's, you see at the end, towards the tail end of the 15-year period, it's starting to hit 6, but it never really went below 6. And then when the recovery was initiated, it starts to go up, right? So under normal recommended adjustment factor, it was able to maintain its quality of 6 and above. Now, if you go at the 2 below adjustment factors, all cultivars went below minimum quality of 6, including cobalt. But the thing to notice here is that that cobalt was able to retain its quality of 6 much longer than some of these other cultivars. And same for at 0.4 adjustment factor. Again, all cultivars went below 6, but cobalt retained its quality longer. But another thing to notice here is even though we reduced the irrigation to 0.4 adjustment factor, after the irrigation was resumed, normal irrigation was resumed for recovery, everything is starting to show upward trend, which means all these cultivars, none of them were dead. All of these cultivars are recovering and responding to that return of irrigation. So basically, this table here translates that graph into numbers. I want you to, I know we're only going to focus on cobalt and Raleigh. So under the recommended adjustment factor of 0.6, Raleigh was able to maintain its quality of 6 or above 6 for 56 days, so about 2 months, versus cobalt for 91 days, so almost a month, over a month difference for cobalt. Under 50%, you're looking at Raleigh for 43 days versus 70 days that cobalt was able to retain its quality above 6. And then at 0.4, 34 days for Raleigh versus 56 days for cobalt. So again, when we say cobalt is more drought tolerant or more drought resistant, the way we are seeing that express in the field is that it's able to retain its color, its quality much longer than, say, Raleigh and other standard cultivars of St. Augustinegrass. So here's the pictures. I just, pictures are always good, and you can see the first row column here is all cobalt. Second is Raleigh. And then I also added TIFF Way in the third column and TIFF Tough in the fourth column for those who might have interest in Bermuda grasses, how they performed in our trial, in Water My Yard trial. But again, focusing on cobalt and Raleigh, this is the 60% adjustment factor. This is what the recommendations, this is what the email that the residents get. And based on if they are following the recommendation that Water My Yard puts out, and they have Raleigh, this is what the Raleigh would look like 70 days into the season, into the treatment, and this is what cobalt would look like. And then this is at the 40% at the lower end. You can still see the difference in color and quality between Raleigh and cobalt 70 days after initiating the treatment. So just a good way to visualize the differences that we saw in our data. All right, one of the last things I want to talk about is, I think it's very important as a turfgrass industry that we go towards sustainability and low input. And water is definitely one of the big sort of limiting resources that we have, and we are trying to reduce the water input on our grasses. And you saw the data on how cobalt has the potential to reduce the water use in turfgrass and maintenance, landscape lawn maintenance. But another input is fertility, is fertilizer, right? Nitrogen. And so this is a study that is led by Dr. Augustine Boeri. He's the turfgrass extension specialist with Texas A&M in Dallas. And this study is funded by Sod Solutions. And in this case, we knew that cobalt has a genetically dark green color. So we were interested to look at what does that mean, or what does that translate to its need for fertilizer, right? A lot of times we are providing fertilizer not just for the nutritional need of the plant, but also for the aesthetics, for the color. And so in this particular study, we used NDVI, which is Normal Difference Vegetation Index. It's really a metrics to sort of quantify the plant health, and it's using a spectral sensor, right? So the data ranges from 0 to 1, 1 meaning very healthy plant, 0 meaning dead or plant or bare soil. So in this study, we had three cultivars: Cobalt, Palmetto, and Raleigh, and all three cultivars were mowed at two different heights. So a lower height of 2.5 inches and higher height of 3.75 inches. And we were interested to see how these different heights of cut may impact the fertility requirement or nitrogen requirement of these cultivars. So in this study was done in 2024, so this summer, and the study started in July. In July, all three cultivars mowed at low and high height were supplied with 0.5 pound of nitrogen per 1,000 square feet. Now, the criteria here was that if any of these cultivars went below, the NDVI value went below 0.6, then we would apply 1 pound of nitrogen. If the NDVI value was between 0.6 and 0.7, then we would apply 0.5 pound of nitrogen. So after that initial application of 0.5 pound of nitrogen across all cultivars, in August, cobalt needed 0.5 pound of nitrogen when it was mowed at a lower height of cut. And that's because its NDVI went below, or was in between 0.6 and 0.7. But after August, in September, October, rest of the season, cobalt did not require any fertility application because its NDVI never went below 0.6. So the total amount of nitrogen needed at lower mowing height was 1 pound of nitrogen for this growing season. Now, when cobalt was mowed at a higher height of cut at 3.75 inches, after that initial application of 0.5 pound, cobalt did not need any further application of nitrogen because it never went below 0.6. So overall, only 0.5 pound of nitrogen was needed when cobalt was mowed at a higher height of cut. Now let's just compare that to Raleigh, for example. Raleigh mowed at lower height of cut after that initial application, like cobalt. So after that initial application, the NDVI for Raleigh went below 0.6, which triggered an application of 1 pound of nitrogen. And after that, Raleigh did not need any further nitrogen application, so with a total of 1.5 pounds of nitrogen at lower height of cut. At the higher height of cut, after that initial 0.5 pound application, Raleigh did not need another application in August, but it did need 0.5 pound of nitrogen to be applied in September and October because its NDVI was in that range of 0.6 to 0.7. So overall, 1.5 pounds of nitrogen. So basically, if you look at it, both Palmetto and Raleigh, regardless of their height of cut, needed 1.5 pounds of nitrogen for the growing season, whereas cobalt needed 0.5 to 1 pound of nitrogen depending on the mowing height. So you're looking at over 30 to 60% reduction in nitrogen use here. But again, the point to be remembered is this is the 1 year of data. We plan to repeat this study next year using the same parameters and same setup. But this is a good indication to what we have been seeing in the field, is that good dark green color in cobalt, and we are seeing that in terms of its potentially reduced nitrogen application. Oh, so here's the photos for you to take a look at it. This is cobalt on the left, Raleigh on the right. This little plot here is Raleigh mowed at lower height of cut with no fertility. And on the right here, you see Raleigh at lower height of cut with 1 pound of nitrogen. And here is Raleigh mowed at lower height of cut and with 2 pounds of nitrogen, right? So you can see the response, the more green, more healthier grass in response to fertility treatment. Whereas when you look at cobalt here, this is cobalt right in the left here, lower height of cut, no fertility. And again, that's its genetic green color that you're seeing here at lower height of cut. This is cobalt at 1 pound, and this is cobalt at 2 pounds of nitrogen. So you don't see so pronounced differences between fertility treatments because of its genetically dark green color.
So the breeding cross that resulted in the development of cobalt was made back in 2010, so about 12 years ago. So in a breeding program, on an annual basis, we make hundreds of new crosses every year, produce hundreds of new hybrids. And so you think of that the 2010 breeding cycle, the hybrids generated from that breeding effort was planted in a nursery in 2010 in Dallas. Those hybrids were evaluated for a couple of years. The ones that were looking promising were then advanced into 2012 breeding nursery through the SCRI project, and they were tested in 7 locations across these 5 states, so Texas, Oklahoma, North Carolina, Georgia, and Florida. Again, after going through 3-4 years of evaluations, the ones that were looking promising were selected and advanced into what we would call SCRI advanced trials in 2016. And they were tested in 8 locations across these 4 states. And they were also advanced in the 2016 NTEP trial, where they were evaluated in 9 locations across these different states. So you see a lot of multi-environment testing was conducted along the way. And while we were conducting these research trials, back in 2018, about 4 years ago, we started collaborating with a couple of sod growers in Texas, Miles Kubitschek in South Texas and Doyle Anderton in North Texas, to try to understand some of the production characteristics like rate of establishment, harvestability, saw tensile strength, regrowth, things like that on farm and at farm scale. And so all that production data and all this research data from multiple environments was factored into making the final decision to release the top hybrid. Its experimental number is 1618 as Cobalt St. Augustine this year. So that's sort of the 12-year timeline, and what it just goes to show that there's been a lot of research and on at the universities as well as on farms before this decision was made to introduce a new St. Augustine hybrid. So what did we learn from doing all these evaluations? What are some of the new and improved traits and characteristics of this new particular variety? Well, cobalt in general has very good turfgrass quality. We knew that that's a consumer-driven trait. You've got to have good turfgrass quality characteristics. So it has genetically dark green color, so it stands out. It has wider leaf blades like Floratam, so it produces a very nice, thick, lush green lawn. It has lower water requirement and fewer pest issues as compared to Raleigh and Palmetto. It has better shade tolerance and winter hardiness as compared to Floratam. And it has wide geographic adaptation because, as you see, that we've tested it in multiple environments, and it has continued to perform very well. In fact, it was one of the top entries in the 2016 NTEP trial. So I'll present some of the data as we go along for these traits and characteristics. But first, I wanted to talk a little bit about the genetics or the genetic composition of cobalt. So in St. Augustine's, there are certain plants that we call diploids. They have 18 chromosomes. They tend to have good turfgrass quality characteristics. They generally tend to have good shade tolerance and cold tolerance, like Raleigh and Palmetto and Amerishade. And they're fertile, so we can make crosses between diploid and diploid St. Augustine grass without any issues. Now, then there's certain group of plants within St. Augustine's that are polyploids, which means that they have chromosomes more than 18. So they would have 27 chromosomes, 30 chromosomes, or like Floritam, 32 chromosomes. These plants are more, in appearance, they are more wild type plants, but they tend to have traits like drought resistance and pest resistance. And so certainly that genetics is of our interest, but because of differences in the chromosome numbers, which 18 chromosomes for diploids and more than 18 for polyploids, when we make the cross because of imbalanced chromosome pairing, the embryo is formed, but the endosperm that provides nutrition to that growing embryo on the mother plant is not fully developed. So if you leave those the seed, the developing embryo on the mother plant, it'll be more like this, more shriveled seed than a plump seed. And so when you put it on germination, they will not germinate or would have abnormal development. So in our program, we utilize a technology called embryo rescue technology, where after making the cross, we harvest the embryo or the ovule 3 weeks after making that cross, and we put it on a tissue culture medium, sucrose-based tissue culture medium. And the idea here is to provide that nutrition that the embryo needs artificially in the lab. And we have been able to develop these interploid hybrids, interploid meaning between two ploidy levels, hybrids using this technology. So a new interploid hybrid goes to the greenhouse field to the farm, right? So just to give you a little bit idea on the amount of work goes behind this. So diploid by diploid cross, where we have no sterility barrier. If we make, say, 100 pollinations, we can expect to get 70 to 80 hybrids coming from that effort. Now, if we go between ploidy levels and we cross a polyploid, more than 18 chromosomes, to a diploid, which 18 chromosomes, it's 10 or 11% success rate. So make 100 pollinations, expect to get 10, 11 new hybrids. And then if you go further, you take that interploid hybrid and cross it back to diploid, we are looking at just getting 2 or 3 out of 100 pollinations. And so, but using this technology, we are able to bring the genetics of polyploids and diploids together, which would not have been possible otherwise. And that's what Cobalt is. Cobalt is a polyploid by diploid hybrid. The question comes that why, what's the benefit of going through this process, the time-consuming and tedious process? And one of the things, the reasons is improving drought resistance. This was our number one goal when we started working on this project 12, 15 years ago, was improving drought resistance. And so this is the study. This was done in Dallas, here in Texas, under rainout shelter, where we put in our advanced St. Augustine hybrids in a replicated format. The way this was study was structured, every week the scientists would go out and take digital images and come and analyze those images, and any plot or any entry that went below 50% green cover under dry down would get 1 inch of water, right? So individually plots were irrigated based on whether they were below 50% or above 50% green cover. And so you can see across the entire summer season, we could calculate how many watering events or how much water was needed to keep a particular entry above 50% green cover. So here you can see the progression of that drought stress under rainout shelter, 17 days after withholding water, 28 days, 84 days after withholding water. And what you see here on the tables, in 2015, the dry down lasted for 86 days. In 2016, it lasted for 91 days. And what here, it shows predicted number of days to reach a turf quality of 5. So quality data is taken on 1 to 9 scale, 9 meaning excellent quality, 1 meaning dead, 5 is right in the middle. So diploids, on an average, require it took 33 days to reach a minimum quality of 5, whereas almost 2 months for interploid hybrids like Cobalt to reach a minimum quality of 5 in 2015. 2016, 22, 23 days for diploids versus 40 days for interploids. This column right here shows a predicted number of days to reach 50% green cover. Again, you can see the difference between diploids and interploids. So it goes to show the benefit of going through the embryo rescue technology process to create these interploids, because what we have learned is that these hybrids can retain their color, their quality, and cover, percent green cover, much longer than diploid plants of St. Augustine grass. So a little bit more in-depth data on the drought. This data came from through the collaborative effort through the SCRI project. This study was done in Dallas, Texas, and Citra, Florida. And this data is from 2017, 18, and 19. The graph here on the left shows TQND, which means turf quality under non-drought conditions, so normal conditions, well-watered conditions. And then here you have TQD, means turf quality under drought conditions. So higher the number, meaning better the performance. So basically, we are looking at plants that are falling in this quadrant. So Dallas is 1618 is the experimental number for Cobalt. And you can see across both locations, Dallas and Citra, 1618, Cobalt had high turfgrass quality under normal as well as drought conditions, right? Now, in the graph on the right, if you just look at the quality under drought conditions and you just pull out the drought data from Citra, Florida, and from Dallas, again, anything in this quadrant is what we are looking for. And again, Cobalt was one of the top performers under drought conditions in Citra as well as in Dallas. So really strong data supporting its potential for drought resistance. Another study, this was again done in Citra, Florida, in collaboration with Dr. John Erickson and Dr. Kevin Kenworthy, part of the SCRI project again, where performance was evaluated under different irrigation regimes. So, I mean, these are the different regimes. Sensor, soil moisture sensor-based irrigation. Irrigation was applied to the plots 8 times per month. So that would be twice weekly, 4 times a month, once weekly, 2 times a month, once every 2 weeks, once a month, and then control, meaning only rain-fed, no supplemental irrigation. And here are some of the pictures to show the comparison between Floratim, which is the industry standard for drought resistance, and Cobalt in Citra, Florida on May 8th, 2018, which is the dry season for Citra. So if you look at the rainfall graph here, April, May, about less than 4 inches of rain each month. So under control, meaning no supplemental irrigation was applied and it was only rain-fed, you can see more green pixels, better color quality for Cobalt compared to Floratim. That trend continues with once a month irrigation, twice a month, 4 times a month, and then those differences even out when we are watering twice weekly between Floratim and Cobalt, and then sensor-based irrigation. These are the set of photos taken on July 23rd, which is during the wet season in Florida. So we're looking at, if you look here, June, July, August, rainfall was about less than, but close to 8 inches every month. And control, meaning no supplemental irrigation applied, and Cobalt, just rain-fed, looks phenomenal here. And you can see the quality, regardless of the irrigation regime, it had really good quality across the board. So again, very strong data right here. And this is real numbers. This is the across all irrigation regimes, data collected in Citra 2018, 2019. On a monthly basis. So anytime you see a letter A next to a number, that means that that particular variety was in the top statistical group. And so A here for Cobalt and TM star, meaning these two lines were in the top. They were not significantly different, but if you see letters that are different, meaning this particular line did better than, say, Cobalt did better than Floritem and so forth. So that's how you would read this table. Anyways, across all these months, Cobalt was in the top statistical group all 10 months when the data was collected in 2018. And in 2019, again, you see all these A's, meaning it was in the top statistical group all 11 months. Data was collected along with Citra Blue in 2019. So that's some of the data from drought resistance work that has been done in Florida, here in Texas, that shows very encouraging results in terms of its drought performance, certainly better than Raleigh and Palmetto, and in some cases even better than Floritem. Moving on to shade tolerance, another very important trait, especially if you're talking about St. Augustine grasses. So this study was done in Dallas in 2017-18 under artificial shade structure, 63% shade. The plots were planted with individual plugs in 2017, and then in 2018, you can see these plots. So here's the data from this study in Dallas, where these bars mean a percent green cover over time. So for example, the first blue bar means percent green cover 22 days after planting, 33 days, 47 days, all the way 78 days after planting that plug. And this 78 days was the end of year one, and that's indicated here in these arrows. Then for 345 days after planting, which would mean next year, after the start of the growing season next year, and all the way data was collected 428 days after planting. An interesting thing to note here, look at Floritem. This was planted as a plug. It started to grow and increase in cover, but then it never really came back from next year. It pretty much had a winter kill. So what you're seeing here is not just the response to shade, but a combination of response to shade and cold. TM star, another variety, was growing in year one, but it really never came back in year two. Same with Delmar. But here's Palmetto. You can see it reached about 50% green cover. Amerishade, which is a standard for shade tolerance, about 55%. Here's Raleigh reaching 70%, and then here's Cobalt looking strong, close to 80% cover under shade. And so I always want to make emphasis, shade is a very unique environment. It's not just shade that we are dealing with. We are dealing with diseases that come under shade. We're dealing with cold stress response under shade. And so what we have seen in Dallas is a reasonably well performance by Cobalt under these combined stresses. This data was collected through the SCRI project for shade tolerance in Citra under 80% shade, North Carolina and 63%, and Georgia under 73% shade. If you look at the top graph, turf quality graph, each of these blue lines show the locations. What you're looking for are entries that are right here towards in the direction of the arrow. Anything here is not as good as any lines that are falling or placing in here. So, so clearly you can see this is Cobalt right here, but doing better than Raleigh. And Cobalt is doing particularly very well in Citra, under 80% shade. Coverage, turf coverage under shade, again, anything right here is what we are looking for. Cobalt better than Raleigh and TM star, and again, doing very well in Citra, Florida. So again, encouraging results from multiple locations into multiple levels of shade. Okay, so now switching gears a little bit and talk about the data that we have obtained from NTEP. If you haven't been on NTEP website, I encourage you to go to this link right here. NTEP has put in a lot of work, and they have made this website real user-friendly, where you can just pull down and ask for data for a particular trait or variety, and you'd get very easy to read tables like this. Anyways, so this is the data from NTEP for turfgrass quality from 2017, 18, 19, 20. So anything in green, it means that that line was in the top statistical group. Okay, so for average, meaning across all locations and across all 4 years, these group of entries were in the top statistical group. So Cobalt, which is 16, 18, right here, in the top statistical group with Palmetto, better than Raleigh. Raleigh's right there at the bottom, and Floritam. You can also look at it individually across each location. So Alabama, Florida, J. Citra, Fort Lauderdale, Griffin, Georgia, Mississippi, Raleigh, and Texas. Again, you can see green all the way across, except for Fort Lauderdale, Florida, and Mississippi State. I'm not sure what happened there, but across the board, high turfgrass quality for those 4 years combined. Spring green up, a very important trait. How well does the grass come out after winter dormancy? This is the data from NTEP on 2017, 18, 19, 20. And you can see 16, 18 Cobalt in the top statistical group, like Palmetto and Raleigh, which was in the top group in 3 out of 4 years. And we know that Raleigh is the standard for cold tolerance and spring green up. And so you can see how Cobalt is performing in comparison to Raleigh. Turfgrass quality during spring again, Cobalt is 16, 18 on top, similar to Palmetto. Here's Raleigh, and definitely better spring green up quality than Floritam. Just real quick, the drought data that was collected in College Station as part of the NTEP. So this is wilting. Data was collected in 17, 18, 19, 20 for wilting, dormancy and drought, and then drought recovery. Clearly, you see Cobalt doing really well for wilting in the top statistical group, like Floritam in this case. And here, dormancy, top statistical group, better than Floritam, recovery, similar to Floritam. Diseases, data was collected in these different locations in Citra, Fort Lauderdale, Mississippi, in Texas, I can't see that. Gray leaf spot data was collected. Here's Cobalt in the top statistical group, except again in Fort Lauderdale. And here's Palmetto for comparison. So if I were to summarize the NTEP data, I think this graph does a good job. Let me explain how this graph is set up. This shows the placement of each of these varieties in the top 25% at a certain percentage of locations. So, for example, this is Cobalt. In 2017, 50% of the locations that conducted NTEP trial reported Cobalt to be in the top 25% of the entries for their location. In 2018, we are looking at 55% of the locations reported Cobalt to be ranking in top 25%. Here's 2019 and here's 2020, right? Comparing that to Floritam, Floritam did not rank in the top 25% in any of the locations in 17, 18, or 19. It ranked in the top 25% in 15% of the locations in 2020. Palmetto here, about 30% of the locations reported it to be in the top 25%. Here's Raleigh, and so forth. And so, again, the take-home message from here is consistent performance across 4 years, 17, 18, 19, 20. And 2 is stability of performance, because 50% or more than 50% of locations reported it to be in their top group. So again, this is just a snapshot of data. If you want to dig deeper and look at a particular location and how this variety did in a location near you, please go to that website. You can end up spending a couple of hours on just digging into that data. All right, switching gears from NTEP onto winter hardiness. This is a question that comes up quite often. So the home for cobalt is Dallas, Texas. This is where it was bred. And in Dallas is in USDA plant hardiness zone of 8A. So which means that we do get cold. Our low temperatures in winter can be in teens, in single digits sometime. And St. Augustine's will go fully dormant during the winter months. Now, this is an anomaly. This is last year. Our temperatures in Dallas on February 16th fell as low as 1 degree Fahrenheit. And it's not just that one day. You can see before and after February 16th, there were 7 or 8 days when we were below freezing temperatures. The soil temperatures never went below freezing, but the air temperatures were pretty low. And so you can imagine we were very concerned how this would impact St. Augustine grasses. So here's a photo 2 months after that polar vortex hit us in mid-April in Dallas, and this is cobalt greening up, coming out of that cold event, historic cold event, pretty well. We did not see any winter kill from that event. Now, 2 things to keep in mind is that, one, as you can see, this plot is well established. You don't see exposed stolons here. It's mature plot. And number 2, during that week period in February, during that polar vortex, we had a nice snow cover. So these plots had nice insulation and winter blanket. So that played a role in how well they recovered from this event. Now, it was a little different in South Texas. These are photos from Miles Kubitschek, a grower who was helping us evaluate cobalt in some of our other lines. The lowest temperature recorded on February 16th in Wharton was 20 degrees. And this is photo from February 17th. You can see a little bit of snow there, 26th. And then this is April 1st. And so here, the temperatures were a little bit higher, 20 degrees versus 1 degree temperature that we recorded in Dallas. But this was a newer planting. The stolons hadn't fully established. And 2, that snow cover only lasted for a day or 2. The temperatures went above freezing and the snow melted, so it didn't have that cover. And so we did see some winter injury, especially on those exposed stolons. But then you come in May, you see a good recovery. And then this is about 4 months and 5 months after that event, cold event, the grass was ready to be harvested. So really encouraging. I mean, it is St. Augustine grass, and so St. Augustines have a limit to their cold tolerance. But the fact that we did not, going through that event that we did last year, we did not lose grass. We did see some winter injury, but a good recovery and harvest 5 months later. All right, so that was a lot about different traits like drought, shade, cold, and so forth. I just wanted to spend a minute here to talk about the appearance of the grass. So cobalt, the leaf morphology of cobalt, the length of cobalt is shorter than Floritam. It's more like Raleigh and palmetto. But the leaf width is similar to Floritam. So it's a bigger plant in that sense that it has wider leaf blade like Floritam, but shorter leaf blade than Floritam. And following the same pattern, the stolons, the internode length, which means the distance between the 2 nodes here, is shorter than Floritam, but the width of the stolons is just as wide as Floritam. So basically what I'm saying is that this is appearance-wise, this is a bigger plant and much more robust plant. And I think that is one of the reasons why it does so well under stress conditions. It's more stress hardy because of those characteristics. All right, so just to summarize, cobalt and what we talked about, good turfgrass quality, good color, wide leaf blades. You can think of it as cobalt has the drought resistance like Floratam. In some of our research trials, we found it to be the comparable to Floratam or better than Floratam. So drought resistance like the industry standard, Floratam, and then the shade tolerance and winter hardiness like some of the Raleigh or Palmetto. So it's like best of the both brought together into this particular hybrid, and that goes back to being able to use the embryo rescue technology that allowed us to do that. And then in comparison to Raleigh and Palmetto, you can expect to see lower water requirements, better drought resistance, and fewer pest issues. So it's an improvement over those varieties as well.
So with that, I think that's the update I had. I wanted to talk to you all about some of the recent work that we've done to sort of try to quantify. We have known the drought tolerance and green color and some of these characteristics in cobalt, but now we wanted to quantify what does that mean for our producers and what does that mean for our consumers in terms of how much less water they can apply and still have healthy grass, and how much less fertility they can apply and still have healthy grass. And so this is our ongoing effort to sort of try to quantify some of those parameters. So with that, I'll end, and I just want to thank everybody who have expressed interest, all the growers who have been growing cobalt. The feedback so far has been very positive, encouraging. I'm very thankful for all of your trust and confidence in cobalt so far, and all of our consumers. I'm excited for you all to start using this grass in your lawns and your businesses. I do believe that this grass certainly has great potential in and helping us reduce the inputs, especially water and fertility going forward, and sort of have a sustainable option for lawns and landscapes. So with that, thank you very much.